know you guys have been dying to multiply some rational expressions all day and all night long. So guess what? You now get the opportunity to do it. Okay, so again, multiplying rational expressions is very similar to when you multiply just two normal fractions. So don't get scared by the polynomials and monomials. It's basically the same thing, just a few extra steps. So don't worry, you guys. All right, so our steps, we're going to factor the numerator and the denominator. We're going to multiply the numerators and the denominators together, because remember, we go straight across when we multiply. We're going to divide out any common factors in the numerator and the denominator, and then we'll reduce the fraction. Guys, so after we multiply the numerators and the denominators together, it's basically going to turn into the simplifying problem that we did in the previous example problem. So after we do all the multiplying, it's basically like what you just did, which is pretty cool. Okay? All right, guys, so let's get started on example 3. So first of all, we factor the numerator and the denominator. Well, if you guys have monomials, all 4 of these are monomials, so I don't have to factor them. I can't really factor a monomial. So that one's donezo. Bam. All right, then we're going to multiply the numerators together and the denominators together. We're going to go straight across when we multiply. All right, guys, so we multiply the numbers together. This one doesn't have a number, so there's secretly a 1 in front. So 1 times 3 gives me 3. Now, when you guys multiply variables with exponents together, you add the exponents. So I have 2 x's here. This x doesn't have an exponent, so it secretly has a 1. So 2 plus 1 gives me x to the 3rd. And y times y to the 5th, well, this one doesn't have an exponent, so secretly it's a 1. And 1 plus 5 gives me 6, so y to the 6th. Yay, my numerator's done. All right, same thing with the denominator. 4 times 6 is 24. X times x to the 4th, there's secretly a 1 on that x, and I'm just going to go ahead and put the y in there so we remember. 1 plus 4 is 5, so this is x to the 5th. And y, doesn't have anything to multiply to, so I'm just going to bring the y to the 1st on over. All right, so now we divide out any common factors in the numerator and denominator. So we're going to be reducing our fraction down. So let's start with the numbers. Okay, so the largest number that goes in the 3 and 24. Holy hot dog, you guys are so smart. It is 3. So I'm going to divide the 3 by 3, and I'm going to divide the 24 by 3. Sorry, that's a division symbol. I know it's kind of wimpy, but I apologize. So 3 divided by 3 gives me 1. And 24 divided by 3 gives me 8. Okay, you guys, so now when we have variables with exponents, we are going to subtract the exponents. But remember, if we get a negative exponent to make it positive, it's going to go to the denominator. So let's see what happens. So 3 minus 5 gives me x to the negative 2. Okay, but x to the negative 2, it can't be negative in the numerator. So we are going to shift it to the denominator to make it positive. Okay, so again, this was x to the negative 2. Okay, and when you guys subtract the exponents, that number technically goes in the numerator. Okay, so when we subtract, this is technically what it is, x to the negative 2 over 1, but we can't have negative exponents. So to make it positive, we just shift that bad boy on down to the denominator. Okay, and then 6 minus 1 is y to the 5th. And since y to the 5th is positive, we can keep it in the numerator. Okay, anytime you guys subtract, that number starts off in the numerator. All right, guys, and if I look over here, there's nothing left to simplify. So that would be my final answer, which you can write it like this. Or remember, you technically don't have to put the 1. Technically, this is the same as y to the 5th over 8x squared. So either of these will be acceptable answers. Wasn't that awesome, you guys?